Log equations with logs on both sides. And here's that type. So what are we going to do here? We're going to contract the left side to get it as a single log. It's a subtraction. We use the rule that log of a quotient is a subtraction of the logs. So here's the quotient. We would contract it back to here. 3x divided by x minus 4. And this side just gets copied down. Then we put 10 as a base on both sides. That's where this method, comes in handy, putting the base of the log as a base on both sides of the equation. 10 to log base 3x over x minus 4 is 3x over x minus 4, and 10 to log base 10 of x plus 10 is x plus 10. Now you're just in a rational equation, so you just use those techniques. Multiply both sides by x minus 4, as long as the solution doesn't come out 4, because it's the equation is undefined there. So x minus 4 cancel out, you get 3x. Over on this side, you FOIL this out, and you're going to get this trinomial. Subtract 3 from both sides. It's going to knock off of this side. Subtract 3x is going to be 3x. Over on this side, 6x minus 3x is 3x. Then you're going to factor this trinomial or use the quadratic formula. This one factors like this. And then use the zero factor principle. X plus 8 has got to be 0, or x minus 5 has got to be 0. So x equals negative 8 or x equals 5, but you got to check both into the original equation. So checking x equal negative 8, here's the original equation. Put the negative 8 in for x right there. And you can stop right there. You don't even have to check the rest of it, because log of negative 24, 3 times negative 8, is undefined. Because log of negative 24 is the exponent you would put on a 10 to get negative 24, and that's impossible. Even if you make this exponent negative, 10 to a negative exponent just means the reciprocal, and there's no way to make the number be negative, so it can't be. Checking x equals 5, you put it in the equation, 3x there, x minus 4. Put a question mark because you don't know if it's equal yet. Put the x equals 5 over there in the equation. 3 times 5, 15. 5 minus 4 is 1. 5 plus 10 is 15. And I can see that the two sides are log 15 because log of base 10 of 1 is 0. Why? Because the exponent you put on a 10 to get 1 is 0. So this here is 0. So this side equals that side, so I can put the equals and it verifies out. Now, just for fun, we can always use our calculator. So we put the left-hand side into the calculator. It has the arrow showing that there's more of it, but here's the whole thing that I put in there. That's the left side of the equation. The right side of the equation is log of x plus 10. Here's the window that was used to finally see it. This curve here is the log of x plus 10. Notice that it abruptly stops right there. That's because beyond negative 10, there's no solution in there, even at negative 10. So that's really actually an open circle. Because even if it's negative 10, negative 10 plus 10 is 0, and log base 10 of 0 is undefined. So that's why it just stops there. And this one stops here, also with an open circle, because x can't be less than 4. It can't be equal to 4, and it can't be less than 4, or this log is undefined. That's why it just stops there at 4. There's 4 right there. Okay, and then when you second calc intersect, as we've done many times, the answer is 5, and that's exactly what checked out. 5 checked out. X equals 5. I think I forgot to write that. So x equals 5 checks out as a solution. And I'm just checking to see if the sides are equal, or what they're equal to. They're equal to 1.1760913, and then the log of 15 is that same number. So everything is good.